We're ready to start section 5.5. This is a huge section in this chapter, not only because it has 3 test questions on it, but because our next section is word problems, which has 6 test questions on it. And for the word problems, you have to know how to solve rational equations or you can't do them. So this is really 9 out of the 17 questions, over half the test involves solving rational equations. So far we've simplified, we've added, we've subtracted, we've multiplied, we've divided rational equations, but this section is solving rational equations. So our final answer will actually be the solutions to the equations, because none of our problems so far have had an equal sign. But 9 out of 17 problems on your test involve solving rational equations. So we need to make sure we do a really good job with this. So a rational equation obviously has an equal sign. That's where the word equation comes from. And it has rational expressions in it, which means fractions. So these would all be examples of rational equations. Remember, rational equations have variables in the denominator, so you can see the variables. The cool thing about solving rational equations, in 5.4, we learned how to multiply everything by the LCD to get rid of fractions. Guess what we do here? Multiply everything by the LCD to get rid of fractions. So if you worked hard on 5.4, it's going to help you with 5.5, because with equal signs, we're allowed to get rid of the fractions, just like with our complex fractions from 5.4. So here are the steps we're going to follow. Oh, look at that. Remember when I said every single problem in chapter 5 has step 1, factor. I wasn't kidding when I said you had to be really great at factoring from chapter 4. So we factor all the denominators because remember, we're trying to find the LCD. We also need to state what values will make the expression undefined. So anything that makes the denominator 0, we have to use that at put it in like in a restriction box so that we can throw those answers out at the end. For instance, if I put 2 in here, that would make this denominator 0, 2 minus 2. If I put 0 in here, that would make this denominator 0. So at the beginning of the problem, we're going to say x cannot equal 2 and x cannot equal 0. If any of our answers come out to be that, we throw them out. They're called extraneous solutions when they're listed up here. So let's say you get 2 answers on a problem. Let's say we solve this and we get 2 and 4 for answers. Well, 2 I would have to throw out because it makes the denominator 0, but I'd still be able to use 4 because it's not in the restriction box. So anything that makes the denominator 0, we put it in the restriction box. Then at the end, when we get our answers, we look up and make sure they aren't there. If they're not there, just put them in solution sets. You're done. If they are, you have to cross them out and pick the one that's not crossed out. If there isn't another one to pick, then we have to write no solution. On this one, the only thing that would make this denominator 0 is 0. So x cannot be 0 on that one. So let's say I had 0 and 5 for my answers on this. I'd cross out 0. That would be an extraneous solution. And then in solution brackets, I'd just put the 5. So then just like on the last, we find the LCD, just like we did with complex fractions. We multiply every term. So let's write this really big, because some students think, oh, I'm just going to multiply the fraction on the left and the fraction on the right. No, you don't get a pick. We multiply every term by the LCD. So every single term has to be multiplied by the LCD. So that says both sides, but it doesn't stress every term on both sides. So I would write that in just so you know. Then our next step is going to be fraction free. and then we can solve. Because that's what happens when you multiply by the LCD. There's no fractions, so we solve that fraction-free equation. Check to make sure none of the answers are in the restriction box, and then put in solution sets whatever answers work. Okay? And this is a must. Why? Because we have to show the reader that we checked up here and made sure they weren't in the restriction box. So these are only the good solutions. None of the extraneous solutions should ever be listed. Okay, so let's see one in play here. So step 1, factor. That's already done. That's already done. Ooh, difference of squares. There it is again. So I think everybody would agree with me. The common denominator, LCD, is x plus 5 and x minus 5. Write everything we see with the highest exponents we see. Then we need to do our restriction box. So x cannot equal negative 5 plus 5 makes that 0, so x can't be negative 5, and 5 minus 5 makes that 0. So those are my restrictions. So if I get either of those for an answer, I have to throw it out. So we multiply every single term. So you guys can really skip this step. We would jump right down to that. I don't even like that. So we multiply the first term by x plus 5, x minus 5. We multiply the second term by x plus 5, x minus 5. And we multiply the third term by x plus 5, x minus 5. So you can see the x plus 5's cancel here. We get 1, so we're left with this, 9 times x minus 5. On the second term, the x minus 5's cancel. So we're left with minus 6 times x plus 5. And on the third term, on this side, everything cancels. Woohoo! So all we have left is 15. So think about what we just did. We went from this ugly mess to this. So what would you rather solve? This or this? Remember when we were doing fractions on the very first couple days of class, and I said, make sure you learn how to get rid of the fractions because we need to be able to do it in chapter 5. Well, here we are getting rid of fractions, but a lot uglier fractions than we had in the first couple days of class. So fractions are gone. Now I just have a nice, simple little equation. Love it. So we need to distribute. Keep in mind this is negative, so you might want to circle it before you do your distributive to remember you're multiplying everything by negative 6. So 9x minus 45 minus 6x minus 30 equals 15. Then we combine like terms, so 9x minus 6x, and then negative 45 and negative 30. So 9x minus 6x was 3x. Negative 45 and negative 30 is negative 75. And that's still equal to 15. Then we add our 75 to both sides. Whoa, I left out a step or two here, didn't I? So then we get 3x equals 90. When we add those and then divide by 3, x is 30. And then I immediately go up to the top of the problem and say, is that in the restriction box? No, it's not. Boom. It's a valid solution. And if you had a lot of extra time, you could do what they're showing here. Plug in the 30 to all the x's and then use your calculator to evaluate. So they're just showing you how to do that. So the first one would become 9 over 30 plus 5, 35. And then 30 minus 5, 6 over 25 minus. And then 900 minus 25, if you put the 30 there, would be 875. So this is what it looks like after you put 5 in, or 30 in for all the x's. And then all you have to do is, so none of this is necessary. I would just go straight into the calculator. So, and then straight into the calculator. So when I do this on the calculator, I'm going to do 9 fraction bar 35 minus 6 fraction bar 25, and I get 3 over 175. And then I had 15 over 875 there, so I'm going to type that in my calculator. 15 fraction bar 875, hit enter. Boom, look at that. Woohoo! Matching numbers on both sides. So that means my solution is correct. So I wouldn't do all this gobbledygook. That's just time management skills. Put it in your calculator, get an answer. Put it in your calculator, get an answer. The two answers should match. If they do, that means 30 is a valid solution. If they don't, that means you need to go check your work. But it could be a problem with the fraction work too. So a little bit ugly to check, definitely. Okay, let's go ahead and go to the next page. I think we have time to do one. So, step 1, find your LCD. Well, there's no factoring. Step 1 is factoring, but there's no factoring. So, the next step 1 or step 2 is write the LCD and write your restrictions. So, I see a denominator 1, I see a denominator 1, I see a denominator of x. So does everybody agree that LCD just needs to be x, right? That's the only denominator. So then we need to say, what makes that denominator 0? Well, the only thing that makes x 0 is if it's 0. So if you have a highlighter, I would practice highlighting those just so you remember to look back up at them later and make sure it's not in there. So one of the questions I get a lot from students is they go, I never know when to write a restriction box. How do I know when to do it? Well, there's a couple things. First off, the directions will say solve. Second, there must be an x in the denominator. And solve will always have an equal sign. So all of those things should tell you. The directions will say solve, which means there's an equal sign in the problem. And if x's are in the denominator, that means it has a restriction box. I was going to look and see if there's any that don't have, like if you had this, 2/3 minus or plus x over 5 equals 7. So that one would say solve, and it has an equal sign, but there's no x's in the denominator. So nothing can make these denominators 0, so I wouldn't have a restriction box. But this, putting 0 in for x would make the denominator 0, so that's why I have my restriction. Okay, so after we find the LCD, the only denominator is x, we multiply every single term by x. And there are 3 terms in this problem, so make sure you multiply all 3 terms by x. So what do we have here? We have x times x, which is x squared, plus, ding, those cancel, 32 equals 12x. So your training from chapter 4 should kick in now. Oh, I'm solving a quadratic. Step 1 is set the quadratic equal to 0. So I have x squared minus 12x plus 32 equals 0. So I have to arrange the terms in the proper order, which they are. Now I'm ready to factor. And we'll pick up from there on the next video.